Just off the shores of Plymouth, in the southeast of England, this research vessel is hoping to collect a sample of the microscopic life that is teeming below the waves. Scientists use a continuous plankton recorder, or CPR, which they submerge underwater and tow behind their boat. Once it's hauled back out of the water, marine scientist Claire Austell looks to see if they have caught any of the microorganisms on the silk scrolls within.
You can see a little bit of green coloration on the silk, that's the phytoplankton in the sample. And if we were to look under a microscope, we'd see all sorts of zooplankton and phytoplankton, lots of different species in the water column.
For 90 years, CPR machines have been towed behind hundreds of boats in every ocean, studying the equivalent of nearly 400 circumnavigations of the planet. In the last few years, scientists have been using the data to see how climate change has been affecting our oceans.
Taking these samples is hugely important, particularly because we have such a long time series. So, particularly because we're able to look at the trends over at least 30 years. So now we have 60 years, up to 90 years of consistent data. We can see trends in warming, in the changes in the acidity of the oceans, how that's impacting food webs, which new species are coming into the area. So these are the kind of key things that we're looking at.
Back on dry land, scientists look through the samples and identify the different species of plankton they collected. There are two main types: phytoplankton, diverse plant-like cells commonly called algae, and zooplankton, animals like krill and the larvae of fish, crabs and other marine creatures. Both are crucial players in the ocean's food chain, but phytoplankton are also behind nearly half of the world's oxygen and help trap at least a quarter of CO2 emitted by burning fossil fuels. But like many marine animals, plankton have been on the move, heading for cooler areas like the Earth's poles. Smaller warm water plankton are also replacing the more nutritious cold water ones, meaning the species that feed on them need to adapt or move too.
If we think about global warming and a warming ocean, we've seen that can have direct, rapid responses on the plankton, particularly the zooplankton, causing them to change in their seasonality, causing them to change in their nutritional quality and the areas where you find them. So we're tending to find that they're shifting out of their normal ranges, which then has an impact on fish that like to eat them.
According to a leaked report by the UN's Intergovernmental Panel on Climate Change, due to be published next year, the total quantity of phytoplankton is predicted to fall by around 1.8 to 6% over the next century, depending on greenhouse gas emissions. Because of plankton's outsized importance, even such modest reductions could mean an eventual loss of up to 17% of marine life.
WION World is now available in your country. Download the app now and get all the news updates on the move.